Okay, Wildcat, so we're going to for modeling behavior, using quadratic functions to model data. The student and teacher works the warm-up together. Warm-up. I can determine a linear regression equation that best models the data using Desmos regression. Okay, so let's go ahead and do that. Okay, so we're going to go to Desmos, click the plus sign, table, and then we're going to do 1. Alright, now we need to adjust the window so we can see our points. We're going to go to wrench, adjust the x-axis to 1 to 9. And then 32 to 41. We're going to zoom out so we can see our points. Right. And then we're going to do y1 shift squiggly ax1 plus b. All right, so our a value is 1.2 and our b value is 31.3. Okay, so our equation is y equals ax plus b, which in this case equals 1.2x plus 31.3. All right, go ahead and finish it up. All right, let's take a look at the next page. Getting started. That might be a bad idea. A 12-ounce can of soda was put into a freezer. The table shows the volume of the soda in the can, measured at different temperatures. Okay, the domain is the temperature of the can, and the range is the soda volume. All right, go ahead and look over the data. All right, number 1, describe the data distribution. As the temperature decreases, the volume decreases and then increases. All right, go ahead and write down number 1. All right, let's take a look at 2. Graph the scatter plot of the data in Desmos. All right, so let's go and do that. So I'm going to go to Desmos. You always want to press the home screen when you're starting a different graph. Exit out of that, plus sign, table. All right, now we need to again adjust the window so we can see our points. So the x-axis, let's go from 14 to 68. And then the y-axis, let's do 354 to 355. And then we're going to zoom out just a little bit. There's our points. All right, let's take a look at the next page. 4.1, using quadratic functions to model data. Let's continue to analyze the data to make some predictions about the volume of soda at different temperatures. 1. Use Desmos to calculate the regression equation that best models the data in the previous activity. All right, let's go ahead and do that. So that's y1 shift squiggly ax1 squared plus bx1 plus c. So our a value, and let's go ahead and round to 4 decimal places, is 0.0009. B equals negative 0.0722, and C equals 356.3530. Okay, so the equation is y equals ax squared plus bx plus c. So using our a, b, and c values, that's y equals 0.0009 x squared minus 0.0722 x plus 356.3530. All right, go ahead and finish up number 1. All right, let's take a look at number 2. State the domain and range of this problem situation. The domain in interval notation is bracket 14, 68 bracket, or in inequality notation it's 14 less than equal to x less than equal to 68. The range in interval notation is bracket 354.9, 355.6 bracket. In equality notation is 354.9 less than equal to y less than equal to 355.6. All right, go ahead and finish up number 2. All right, let's take a look at number 3. Use the regression equation to answer each question. Determine the y-intercept and intercept its meaning in terms of this problem situation. Okay, so we're going to go to Desmos. There's our y-intercept. So that's 0 degrees Fahrenheit, and the corresponding volume is 356.3534 centimeters cubed. All right, go ahead and finish up 3A. And then B, determine the x-intercept and intercept the meaning of each in terms of the problem situation. There are no x-intercepts because the volume of the soda will never be 0 centimeters cubed. All right, go and finish that up. All right, let's take a look at the next page. All right, the teacher works for A and the student works for B. 4. Predict the volume of the soda can when the temperature is A, 20 degrees Fahrenheit. So to do that, all I have to do is graph x equals 20, and the corresponding volume is 0.2619 centimeters cubed. All right, go ahead and work for B on your own. And then mark out number 5. All right, let's take a look at the next page. 4.2, analyzing a quadratic model and its inverse. Arlington City Police Department is offering special classes for interested high school students this summer. Elsa decides to enroll in an introductory forensic science class. On the first day, Dr. Suarez tells Elsa's class that crime scenes often involve speeding vehicles which leave skid marks on the road as evidence. Taking into account the road surface weather condition, the percent grade of the road, and vehicle type they use, this function is f of s equals 0.034 s squared plus 0.96 s minus 26.6. Determine the length of the feet of skid marks left by a vehicle based on its speed s in miles per hour. 1. Complete the table based on f of s when Desmos. Okay, so let's go ahead and do that. So Desmos, I need to go to desmos.com. I'm going to go to scientific calculator, and I'm going to put in 0.034 s squared. It's going to give me an error, but that's okay, plus 0.96 s minus 26.6. Press an error, who cares? I'm going to press s equals 25, and then that gives me 18, and let's go ahead and round to one decimal place, 18.7. Okay, then I type in 30, and then that's 32.8. Type in 45, and that's 85.5. And then I'm going to type in 55. That's 129.1. And then I'm going to type in 60. That's 153.4. And then I'm going to type in 75. and that's 236.7. Then I'm going to type in 90. That's 335.2. Then I'm going to type in 100. That's 409.4. And then I'm going to type in 110, which is 490.4. Okay, so go ahead and complete the table. All right, now according to the table, what are the domain and range? Okay, the domain is 25 to 110. And in equality notation, that's 25 less than or equal to x less than or equal to 110. And then the range is 18.7 to 490.4. And in the equality notation, it's 18.7 less than or equal to y less than or equal to 490.4. All right, go ahead and complete number 2. Number 3, determine the quadratic regression using Desmos regression equation. y1 squiggly ax1 squared plus bx1 plus c. All right, let's take a look at the next page. Go ahead and mark this page out. The student works 7A, 7B, and 7C. All right, let's take a look at the next page. Mark this out. Mark this page out. Mark this page out. All right, and go ahead and complete your notes and assignment and have a wonderful Wildcat day.